So linear equations. Linear equations are called linear equations because they are the equations of lines. Linear being the adjective form of the word line. Okay, so a couple things to know. One is n equations with n unknowns. However many variables you have, so let's say you have some word problem, who cares what it is, but or a story problem, or maybe it's an algebra problem, and you have an x, a y, and a z. If you have 3 variables, you need 3 equations, 3 separate, distinct equations to solve for all of them. Okay. Let me say that again. So if you have an equation with an x and a y, a z, or an a b, and a c, and you only have one equation, there's no way you're going to be able to solve for what a, b, and c, or x, y, and z equals with just one equation. You need more than one. You need exactly the same number of equations as you have variables. You'll see this played out a number of times in the problems that you do. That's not to say that you always need 3 equations to solve for something. And that's, you just need 3 to solve for all 3, or 4 to solve for all 4, or 2 to solve for 2. You may be able to solve for differences between them, or for a single variable. So let's say you have, you know, x plus y equals 5 and z equals 6. Clearly, you can solve for z, even though you don't actually know what x and y equal. So this is an example of, you can solve partway with fewer equations than you have variables, but we can't tell what x and y are. X could be 10 and y could be -5, x could be 1 and y could be 4. There's an infinite number of combinations here, but there's only one thing that z could be. So we can solve for z, but we don't know all 3 variables because we only have 2 equations. Now if we were given a third equation like x equals 2, then we'd be set. You get the idea. Alright, so that's one thing to know. Linear equations then, like I said, can be used to give you lines. We'll talk about coordinate geometry shortly, actually, after quadratic equations. See how it says that down here? Pew, pew. Multiple ways to solve your linear equations. There's combination, substitution, and when you're doing multiple choice questions, plugging in. Let me show you what I mean by combination, substitution, etc. Whoops. Anyway, combination first. So, Jason and Amanda, wrong color. Jason and Amanda together have 18 apples. If Amanda gives Jason 4 of her apples, then Jason will have 5 times as many as Amanda. How many apples did Amanda initially have? So again, this is a word problem. Maybe your head's spinning a little bit. Keep a cool head. Try and turn it into the obvious math. The first one, there's a period. Clearly that's its own equation. Jason and Amanda together have 18 apples. So J plus A equals 18. That's one equation and 2 variables. We're going to need a second equation in order to be able to solve for both of them, and you know what? That's what's coming next. So if Amanda gives Jason 4 of her apples, then Jason will have 5 times as many as Amanda. Okay, so Amanda's giving 4 to Jason. So A minus 4. So if she gives 4, then he will have 5 times as many as she does. So we will need to multiply her number times 5 to equal what he has. So 5 times what Amanda has after she gives 4 will be equal to what Jason has when he has 4 more. So there's our 2 equations. We don't necessarily have to go any further than that in terms of the initial setup, but we are going to have to go further to actually solve it. So we do have some answer choices here. Now what's the combination method? The combination method is treating equations like numbers in a way. You can add and subtract equations from each other as long as they have the same variables in them. So first off, of course, we need to simplify this guy because this is kind of ugly. So we have our friendly one, J plus A equals 18. Then we have this other one here. So 5 times A minus 4 equals J plus 4. That equals 5A minus 20 equals J plus 4. And we want to get all the letter variables on the same side of the equation the way we have it here. So we would subtract a J from both. Let's add 20 to both sides first. So 5A equals J plus 24. And then subtract a J. 5A minus J equals 24. So from here, you have to decide whether you want to add or subtract your equations from each other. Note that we want to actually solve for Amanda. So if possible, we want the J's to cancel themselves out rather than the A's. So we can rewrite this as A plus J equals 18. That's the same thing. And then we have this one. So if we add 5a minus j equals 24, plus the entire equation a plus j equals 18. 24 and 18, 242. Negative j plus positive j is nothing. And then 5a plus 1 more a equals 6a. So 6a plus 0 equals 42. 6a equals 42. Therefore, Amanda originally had 7 apples. Ta-da! Answer choice C. Pretty cool, right? So treating it as a whole equation, sometimes there'll be an obvious way that you'll be able to cancel out one of the variables, and in those cases, combination may be your best bet because you don't really have to do as much like math because the parts cancel each other out. It's not always the case, though. Sometimes substitution, note the clever change of title with the exact same problem. Substitution is the method that most of you are probably more familiar with. So again, we have our same equations, j plus a equals 18, and we also had 5 times a minus 4 equals j plus 4. Okay, so and then we got this out to 5a minus 20 equals j plus 4, and we can do it as 5a minus j equals 24. So we got it that far. That part was the same both ways. The substitution method involves taking the simpler of the two equations and solving for the variable that you don't want. You then plug that into the other more complicated equation, and that solves for the variable you do want. So since we ultimately want how many variables Amanda had. Amanda has only one variable, but she does have more than one apple. So because we want to solve for a, we solve this equation here for j. So this would be j equals 18 minus a. Well, what does that do for us? Now we know what j is. We can plug this in any place that we see j in the original equation. So now this one becomes 5a minus the quantity 18 minus a equals 24. And now it's down to one single equation with one single variable. That's all we need to solve for a. Now, maybe you can already see that it comes out exactly the same, but maybe you can't, so let's just go ahead and do it. So 5a minus 18 plus a, because remember the minus minus becomes a plus again, that equals 24. To get rid of the 18, we add 18 to both sides. So this ends up being 6a equals 42, again, and a equals 7. It will always come out to be the same answer, whether you do combination or substitution, or even plugging things in, because the math stays the same. Just do whatever's easiest for you, whatever comes to you first. Again, as long as you do the math right, they all come out right. You know, it's just you have to do it right. But that's true of the whole test. Okay, so that was the substitution method. Finally, plugging things in. Plugging things in is a little bit trickier, and it does require you to still do some of that initial algebra. So you still have to determine that j plus a equals 18, and that 5 times a minus 4 equals j plus 4, and get that to 5a minus 20 equals j plus 4. 5a minus j equals 24. Or something along those lines. You don't actually have to do all of that. But what you're doing then is plugging in these various answers into the value for a to see if you can get a plausible value for j. First off, you need Jason and Amanda together to have 18 apples. So if Amanda starts with 4 apples, for example, and she gives away 4, she's going to have 0. And will Jason then have 5 times as many as Amanda? No, she'll have 0, and he will have, so if you can just do a chart even. You don't even necessarily have to do that. Sometimes you'll still have to do the algebra, but sometimes not. So if this is Amanda's value, then Jason must have this. So if she has 4, he must have 14, because it always has to add up to 18. Now, if she gives him 4, he'll have 18 and she'll have none. Is that 5 times this one? No. Okay, if she has 5, he has 13. If she gives 4 of those away, then she has 1 and he has 17. He has 17 times hers. Still not right. We already know it's C, but just to show it as an example, if we go too high, so if she has 9, that means that he also has 9. So if she gives up 4, then she has 5 and he has 14. That's not quite 5 times her number. So you can tell when you've gone too far. And remember, when you're plugging things in, it's often best to start with choices B and D, and then if you can tell whether you need to go higher or lower, you should only have to do the problem twice. So on this one, I guess I didn't follow my own good advice, but I was too eager to show off the chart, I guess. Anyway, note that I still got the right answer, so if you don't start with B and D, or if you do B and D and it doesn't really correctly show you whether you needed to go up or down, it's okay to do all the answer choices. Okay, so here we have a system of equations. Note that we have two equations and two variables, so this should be solvable. And so we can do it multiple different ways if we want. So we have 2p minus 3 halves q equals 18, and then q minus p equals 3. And whichever one jumps out at you is fine. We ultimately need the value of p, so we'd want the q's to cancel each other out. You know, I personally, I learned the substitution method. I don't think I was ever taught the combination method when I was, you know, in high school, or when did I learn algebra? High school, I guess. Anyway, but either way will still work. And now numeric entry, of course, you don't have the option of plugging in answers from the entry. So it's in your best interest to be able to, or most able to, it's in your best interest to be most able to do substitution and combination. Relying on plugging things in is relying on a alternate strategy, and that alternate strategy simply will not apply in numeric entry. So one of the other two should be your go-to choice, or both of them, but plugging in is still a solid choice when you can do it. Anyway, so if we were to just, remember, we're trying to solve for the value of p, so we would want to solve this one for q, plug that into this, and then we'd have our answer. So we solve for this guy for q. Q equals p plus 3, because we added p to both sides. Now we can then plug this in over here. 2p minus 3 halves p plus 3 equals 18. Now personally, I don't like fractions. Well, I mean, I like them well enough. You know, they're pals of mine. But sometimes I just don't want to deal with them. You have any friends like that? You probably do. I would actually just multiply this whole thing by 2 just to get rid of the fraction. So this would then becomes 4p minus 3 times p plus 3 equals 36. And, you know, as long as you do the whole thing to the whole equation, you're not doing anything naughty. And note then that I didn't have to have a 3 halves p in here. Okay, so then we multiply this out. 4p minus 3p minus 9. That's supposed to be an equals. 4p minus 3p becomes 1p. Add one more 9 over here. 1p equals 45. So p equals 45. See how that works? Pretty straightforward.